Thank you everyone for joining us this afternoon or evening, depending where you're at, for part 2 of our warranty and code review. The marketing team will be working on posting this presentation and the first version of it, and also the ones that Chris Hines did 2 weeks ago pretty soon. So go out and check those out if you get a chance. And by way of introduction, I just want to walk through who BORAL is if you're not familiar. BORAL is based in Australia. They do some work in Asia and the Middle East, but in North America, we're primarily a cladding company, doing products like roofing, trim, siding, windows, and obviously brick and stone. One of the things that I've really enjoyed as I've been working for BORAL is their stance really around sustainability, or being very responsible in how we manufacture. A lot of our stone plants are using closed loop water reclamation systems, and some of them are in places that are often in drought situations. And so the ability to take little to no water from the local community, I think, is a good thing. We've got a brick plant that runs off the methane that's produced from a landfill a mile or two down the road, and they use that to heat the kiln. So again, reducing the amount of other gases and energy that they would need to use to run that kiln. So trying to be smart in how we produce the products. BORAL is the leading manufacturer of 5 different stone brands. If you need some more information, please follow up with us on those. And also just a quick list of some of the other siding and roofing and window and trim products that we produce and sell. If you need more information, just jump out to boralamerica.com and you can find some more information there. Just as a quick foundation and recap, in our first presentation, we spent some time talking about the code requirements for the actual units. And I think there's 2 that we'll probably focus in again tonight. One is going to be the average thickness, that 2 5/8, and also the weight. The actual units themselves shouldn't weigh more than 15 pounds per square foot, typically are less than that. And then for the lath and scratch coat setting mortar, we usually add an additional 8 to 10 pounds. So the max would be 25 pounds per square foot for code compliance. There's a lot of testing that should be going into any stone that meets those requirements. And so again, just a recommendation, please make sure you're looking for stones that have done some third-party testing. We also took a quick look at the building codes and what they say for installation. There's a lot of information that talks about the water resistive barriers, the flashings, the clearances to grade, and we'll focus in tonight more on the flashings and clearances that are required for an installation. We're going to do most of our work out of the NCMA-MSV installation guides. It's the installation guide for our stones. We're going to be working on the most current edition that came out in September of 2019. Now, in our last presentation, we took a few minutes to talk about some of the different ways that moisture and vapor will move through a wall, whether it's through HVAC systems, it might be a vent for a fan, the hot and cold weather that we get in summer and winter. And it really doesn't matter if you're in the north or if you're in the south. Energy loss is a concern, and adding insulation to slow that down is part of it, slowing down leaks in walls. And then obviously rain events. We looked at some different buildings and what might be going on if moisture is getting in. So let's take a look at another one. This is just a typical residential project. And if we take a look, we've got a couple of problems. One, we've only got 1 layer of water resistive barrier in most areas. They put 1 strip of a number 15 felt there, and you can see if water does get back to that house wrap and travels down, it's now going to get directed behind that number 15 felt, not going to get pushed outside of it. We see a lot of windows, again, that have not been taped off properly. The installer should not have covered that all up. We've got some exposed wood at the sill plate. That's going to be a potential area for some mold, mildew, and rot. And then we can see a lot of dirt and mud that have splashed up on the foundation. If we install directly to that, we've got a pretty good potential for stones to debond because that dirt and mud acts as a bond break. We took a look at a picture like this, and again, really focused in on the area inside of the red, where again, we've got the improper tape on the window. We do have 2 layers of paper, and that's correct, but we did talk about this flashing. code requires a piece of flashing in between two dissimilar materials or two different types of cladding. And the idea is that any water that gets behind the cladding above should be getting directed out over the face of the cladding below it, not directed back in behind. But in the setup that we see in this picture, any water traveling down this primary WRB is going to get driven back in behind that black paper. It's not going to jump on top and then jump again to get over top of that flashing. It's a reverse flashing. So they should have either cut the primary WRB to tuck those flashing and paper in, or used a flashing tape on top. So what does a mistake like that cause? What kind of issues can we see? What we don't see in this picture is about 2 or 3 more stories of stucco or eaves up above. They made a mistake and actually caulked the drainage shut at the bottom of the east system. That water got directed behind the steel panel. The steel panel did not have flashing to direct the water out on top of the stone, so all the water got directed back in behind the stone, and they also made a mistake to bury that stone into grade. And you can see on the inside some of the rock that's already beginning to develop on the inside. In this picture, again, you can't see the 2 or 3 stories up above, but we can see some water sitting in the stone here, and most of it looks pretty dry. So that would be an area of concern. As they began to tear off the stone, they began to find a lot of damage back in behind, and what they found is that, again, it was reverse flash. The flashing was on top of the paper, directing the water from the 2 or 3 floors above back in behind the stone rather than dumping it out. So how do we prevent against some of these issues? What are some things that we should be looking for? What are some of the details that we're going to use? That's what we want to cover tonight. First thing that we would recommend is require a mock panel. And it really doesn't matter if it's a residential or a commercial job. If you've got a residential project and you've got maybe a new design or some new contractors, it's not a bad idea to get them out around the house and work through the sequencing. In a commercial job, it's not uncommon to have some type of a mock panel, but to have one this extensive is important. To have the windows and the penetrations and all the transitions between the dissimilar materials, it gives us a chance to make sure that the right products are being used at the right places. To talk through that contractor sequencing, to know who's going to go first, who's going to put the flashing in, and who's going to come in second, and everybody knows what to look for. We can check for the proper flashing placement. We can talk about those material transitions. Is there going to be a soft joint between that brick and that stone? And also it helps us to handle any aesthetics disagreements. And then finally, make sure everybody's happy with their tight fit look or their grouted install, depending on what they have selected. If there are going to be penetrations coming through the wall, it's a great opportunity to show what those trim pieces will look like at those penetrations. And it's also a chance to talk about mortar colors. These are popular. If you've got a lighter colored stone and you want to use a lighter mortar, it's good for that owner and architect, designer to see what that colored mortar looks like, to make sure they like it before it goes on that completed project. It's a lot harder to change it once it's on a finished job. A good chance to check the level and plumb of the install, make sure we're blending colors well. This is a nice smaller mock panel, but it's got all the different claddings, it's got all of our different transitions on here. And if we've agreed that this is what our stone install should look like, and I know this is a different profile, but it kind of proves the point that if we end up on an actual job site and we see all the little stones got used up in one spot, we've got some really long head joints in here, and then we obviously didn't chalk lines because we can see how we're tailing off and running downhill. If this was our mock panel and this was the control that we were using for the installation and this is what went up on the job, I think that we wouldn't have nearly the arguments we have today. So it's important to have those mock panels. The other thing that a mock panel gives us a chance to do is we could actually do some testing on it, or making sure that we've got flashings in the right place. In this case, we're going to look at this transition between the wood and the stucco. And if all we do is come and install our second layer of paper where the stone's going to go, put our metal lath on, put our stone on, in about 6 weeks, maybe 6 months, right in between the stone and the stucco, they're going to move at different rates. And that's going to open up a crack. typically big enough for water to run into. They call that bulk water intrusion. Now, if water hits the middle of a stone system, typically it soaks into the stone and the scratch coat, and any that makes it through the paper will travel down and exit out. But if we've got a crack, a hairline crack big enough for bulk water to get into, that's where we see wall systems that get oversaturated, and over periods of time, water begins to work on the sheathing and cause damage there. And so there should be flashing in between those two per code. And if we have done a proper mock panel, we would know who was responsible for that flashing piece. Is it the stonemason? Is it the stucco contractor? And when the other trade shows up to do their work, if they don't see that flashing there, they can go and notify the GC or the designer or the owner and get that corrected before they install. That way we don't have those issues in the future. Now, in that NCMA guide, there are quite a few different details, over 40 of them. And so we would recommend getting a copy of that guide. We're not going to go through all 40 of them right now. We're just going to go through some of the more popular ones, the ones that we get the most questions on. But these are available both in PDF and CAD format. Now, probably the most common question we get is clearance to grade. What we're seeing here is our 2 layers of paper and our metal lath and scratch coat, all terminating on top of a weep screed. And then that weep screed is going to be about an inch, at least an inch below the sill plate. And it serves 2 purposes. It's a drainage spot for our stone system. It's also that capillary break to keep water from wicking up into the bottom of the wall system. And that clearance allows us a couple of things. It allows for termite inspections and to keep that water from wicking up. And so code says we need to be 4 inches away from grade, 2 inches from a paved surface, and then ½ an inch if that paved surface is part of the foundation that the wall is on. Think of a porch, where if that's part of the foundation, it's really not going to move at all because it's part of the foundation that the home or the structure is on. Now, the reason that we look for that is it's a trade-off. We're using a lightweight concrete that wicks water, so we don't want it to come in contact with grade. We want that open exit point for water. If we do put it in constant contact with grade, we've got potential for efflorescence and staining. That gap gives us a place for termite inspection, and to be honest with you, it's a requirement in most areas for code. Now, manufactured stone is not different from other cladding products. If you look at a wood siding, vinyl siding, cement board siding, they have clearance requirements also. And if you look close enough at this wood siding, you can see that it's beginning to soak up water and it's beginning to damage the stone or the wood siding there. Brick is an amazing and beautiful and hard product, but if exposed to enough de-icing salts, that can begin to cause damage in even the brick and the grout joints that are there. This is an eave system. Eaves should have a 6-inch clearance at least, and it was buried down into grade. Now, as that system tries to drain, it can't, and that can cause some damage. And then obviously with a sidewalk that's poured right onto a manufactured stone, as it heaves a little bit, it's causing damage. So some different ways that we have seen that folks are trying to handle that clearance. In some commercial jobs, they're pouring or adding bumpers that are part of the foundation. That way by code, they're allowed to come down to within ½ an inch. And now it looks like that stone is actually sitting or supported rather than floating up above a sidewalk. An application like this could work in a commercial or a residential application. They've bent a coil stock that might either be similar to the stone or maybe to the mulch out over top of a piece of 2-inch rigid foam, but it's tucked back in behind the 2 layers of WRB and weep screed so that any water that travels down gets out and doesn't get driven back in behind. They do that the whole way across the stone system. Now, when they come in to backfill, they still need to stay down that 4 inches to meet the requirement for code. But now that stone looks like it's supported, it's a much cleaner, much nicer finish. Now, anytime we transition from foundation to framing, code says that we need to handle this transition somehow. Now, we've got 2 different options. The first one is to bring our 2 layers of paper, our metal lath, terminate them on top of some flashing. And then from here on down below, we can either apply directly to clean masonry, or we can shoot lath on if it's not clean to get a better bondable surface. And now we can come down to within 2 inches to grade this pop-up, 2 inches to grade, and 1/2 inch to a paved surface, as long as we've handled the fact that that paved surface is not going to heave substantially and cause damage. But what we're seeing in this detail is this flashing piece that needs to have a 3.5 inch attachment flange, has a sloped bend to it, a bead of sealant underneath. This is required. If we follow the lines from the weep screed up, you see that the weep screed or a drip screed or a casing bead would be optional. The reason is we have created a drainage point for the system with this flashing, and we've created the capillary break. That weep screed is kind of redundant. It's doing the same thing, but it's not dumping the water out over the face of the stone. It would dump the water right on the stone below it, which is not good. So we have to have the flashing. The casing bead would be optional. It would look a little like this. You could remove that casing bead that's there, or I'm sorry, the weep screed that's there. You could bring that stone down a little bit further, and if you can get that metal to kind of be a similar color to the stone, it's not that noticeable. And again, we can come down within 2 inches to grade now, or 1/2 inch to that paved surface. If you don't want to see that running across at the sill plate, our other option is to put some flashing at our transition point between the foundation and the wood, and then carry our 2 layers of paper and our metal lath down to the weep screed, but it needs to stay 4 inches from grade, 2 inches from a paved surface, because we don't want water wicking its way up and having any chance to get to our framing. Now, in both of the details, I didn't highlight it in the first one, I should have, but in the second one, we can see this flashing before the 2 layers of paper. The reason we see that on there is this is a very fairly vulnerable point in the construction. If we only bring our weep screed an inch or so below this sill plate and have our paper on top of it, water could wick up and get back in behind here fairly easily. So what we're seeing in that detail is that primary WRB gets flipped back up. We're going to come in to expose the wood there, come in with some flashing, some metal or some peel and stick there. Next, we would install our weep screed and then bring our primary WRB back down over top of it, and then our secondary layer and our metal lath. That way we know that this transition point is properly protected. Stone coming up in a wainscot application, or this might be stone coming up, so let's say to a first floor, and then transitioning to a different cladding, often using a water table sill as that transition point. This is a pretty common application. What we're seeing is the primary WRB that comes down either needs to be out over top of the flashing here. That's going to take all that water from the cladding above and direct it out. We've got a bead of sealant underneath. Or if the primary WRB manufacturer doesn't recommend cutting, then we need to find out from them what type of tape they should be using to tape that flashing in. You'll also notice that there is no bead of caulk in here. Unfortunately, on some jobs at the end, somebody takes a tube of caulk and goes around and seals up all the open spots. Unfortunately, if somebody puts a bead of caulk right in here, any water that gets back in behind the siding is either going to dam up, or worse yet, get driven back in behind the stone. The last thing I'll point out here is you are seeing a bracket underneath that water table sill. If you remember at the beginning of the presentation today, we talked about the max average thickness is 2 5/8. Most water table sills are about 3 inches thick. That way they're shedding any water out past the face of any of the thicker stones. And so technically by code, they would need some type of an anchored support. They're no longer just an adhered veneer. Now we recommend 2 anchors per water table sill. Now you would need to put blocking back in behind in order to anchor those properly. If that blocking is not present, then you're only going to be able to anchor those into framing, which means they may only get 1 of those anchors per water table sill. Why is it important to keep that gap in between claddings open and flashing that water out? Well, you can see the bead of sealant in here. Any water that got into the cladding system above came down and couldn't get out, so it got directed back in behind. And as we tore off the stones, we found the proper layer of WRBs. The metal lath was wrapped around the corner properly, but we found that the water had finally worked its way into the OSB, and as that OSB swelled, it pushed in those 2 different directions and split those corners apart. On this project, it looked like everything was right: stone, water table sill, flashing, and then siding. As we walked around the corner, we found that flashing was just nailed on top of the primary WRB. Now any water that travels down that primary WRB is likely not going to jump out on top to the flashing for us. It's going to get driven back in behind the stone. So again, a situation of reverse flashing. Let's talk about penetrations that are coming through the wall, whether it's for a gas line, a dryer vent, or electric, as you see in here. We need to make sure that those have been properly handled. We want them to be air and water tight. There are a lot of great details in our installation guide. I would also suggest that whoever the primary WRB manufacturer is, they likely will have some really great details on how to handle those penetrations coming through the wall. But I would suggest that holes like these coming through our primary WRBs, if not addressed, are more dangerous today than they were 20, 30 years ago. If all we do is poke a hole in our black paper and stick that through the electric, and then cut our metal lath out around the outside and install our stone over top of it, we've created a spot where moisture and bugs could potentially get into that wall. Now, I've put a picture up here of the single pane window at my house. I live in an older home, and back when I used to travel a little bit, when I went out of town, my wife would turn the heat up. And when I would come home and it was cold and dry outside and warm and higher humidity on the inside, we would begin to see those droplets happening on those single pane windows. Now, that kind of stuff was also happening in my walls because they're not insulated well, but I live in an old house that's drafty. I see it in my energy bills, and that probably helps to dry those walls out a little bit. I would suggest that that is not how we're building homes today. We are sealing up as many holes as possible. Often homes and buildings are performing blower door tests to make sure that they meet a requirement. If they're finding leaks, they're going through and sealing those up. And in a home like that, a hole that has not been handled properly becomes a place where water can get in. Now, the folks over at Construction Instruction have a wonderful app. They've got some great videos, and I took just a screenshot of one of their videos because it tells the story better than I can, where some warm, moist air finds its way into a wall cavity through something as small as an electric socket. And if it warms up that wall cavity enough and finds an exit point that has not been sealed and flashed properly, we begin to see condensation. That cold, dry air meets that warm, moist air. And if water is dripping right underneath this electric line over 3 years, 5 years, 7 years, maybe less, eventually that's going to begin to rot out that wall cavity. So it's important that when we approach a project, all those penetrations have been handled properly. I would suggest to the contractors, if you do not see those penetrations handled properly, if it's your job, you need to fix them. If it's not your job, you need to go get somebody and have them fix it before you install over it. You do not want to accept a wall that is not properly prepared. Let's talk about soft joints a little bit. Chris covered this a few weeks ago. If you didn't hear it, go back and grab that one. It's worth the listen. But anytime we transition between dissimilar materials, we talked about the flashing that's required for those horizontal transitions. But the same thing goes. We need to handle these horizontal transitions properly. That J channel is going to expand and contract at a much higher rate than stone and grout does. Same thing goes if that were brick or cement board or vinyl siding or wood siding. They move in at different rates. And so what we need to do is have a soft joint in between to protect water from getting in. Again, if that J channel expands and contracts a lot, we're going to get a crack probably big enough to slide your credit card through for bulk water to begin to penetrate into that wall system. And if it works sideways, it can begin to cause some damage. And so what should that soft joint look like? Well, typically it's about a 3/8 gap. And then it's typically filled with some type of backer rod and sealant. That allows those two dissimilar materials to expand and contract at different rates without damaging each other, and also prevents that bulk water intrusion. Here's a picture of a soft joint in between two dissimilar materials. That's great to see, but you can see that stuff begins to pick up some dirt and just isn't really a good match for those materials. We do have a product called Flex and Dry tape This would be a soft joint replacement. The nice thing is you don't need any caulk anymore. It installs faster and will last longer than the sealant that you're using. Another place that we should be concerned with that differential movement is between windows and stone. If you look close enough, you can see the hairline crack. It's worked its way around all four sides of this window. This is a new building. No one has taken occupancy yet, and we're already seeing those cracks begin to open up. What's happening is that window is expanding and contracting. The grout and the stone are not. Unfortunately, with windows, when they expand and contract, and if they try to expand out and can't because they're hitting brick, stone, siding, something like that, they begin to cause damage, and a lot of times that moves internal. It might be windows that don't open well, or worse yet, the seals that are inside of a window that are meant to catch water and direct them back out can crack and allow water to begin to penetrate inside of that wall system below the window. If you take a look through most window manufacturer installation instructions, they're going to ask for that soft joint between siding brick to have flashing back in behind, all of that to protect that window. And so what is that going to look like for stone? Well, we want to see a soft joint underneath a piece of head flashing, and then our paper and lath over top. We want to take any water that is traveling down that wall above the window and direct it out over the face so that it's not dropping on top of the window. We need that 3/8 gap around the sides. And the same thing goes for underneath. Now, what it's going to look like with a stone job is something similar to these pictures. We've got our gap that we can come back through and fill with backer-rotted sealant. I would suggest that probably from the sidewalk on in, to be honest, you will see the gap in between those two. As you get back to the sidewalk on out to the street, it really becomes very hard to see. But the important thing is that by creating that soft joint on all four sides of that window, we've now given that window the opportunity to live its lifespan. If it's supposed to be a 20 or a 30 or a 50-year window, it's got a better chance of living that long. If we install our masonry right up tight against that window, there's a better chance for that window to fail early, and for window manufacturers not to cover that warranty because of that masonry bind. And again, we think that flex and dry tape would be a great solution for around those windows. It creates a better blend with grout or a better shadow with the black than most sealants are. It keeps your windows looking very crisp and clean. Let's take a look at roof lines. In this situation, we've got stone that's installed down on top of the roof line, and we've got a roof going up this way, and a gutter, all pushing water down this corner. We can see it shooting over towards that window. I hope that window is prepared properly because it's getting saturated pretty often. What we should see is a piece of kick-out flashing that directs water back into the gutter. Right now, there's no kick-out flashing, so water can shoot over. If we had kick-out flashing there, it would direct it back into that gutter. What would that kick-out flashing look like? Well, it's a three-sided piece that tucks back in underneath the step flashing. And now as water travels down, it can help to channel that water back into the gutter. Now, in this project that we see here, we can see some water trailing over. And they were also getting water inside dripping from the window. And so as we climbed up on a ladder, we were able to see what looked like kick-out flashing. And if you remember, kick-out flashing is three-sided. Should be underneath, up the side of the wall, and out in front. But what we found was it was just a two-sided piece of step flashing. So it was underneath the shingle and up the wall. There was some sealant here, but there was a big gap right down here in the corner. And all the water that was running down was now getting driven back in behind the stone. As they began to peel some of the stone off, you can see the damage in that OSB. The other problem that we've got right now is that stone is installed down onto the shingles. So every time those shingles get wet, they're going to start pulling water, wicking water up onto that wall. And if we've installed stone down onto shingles, that typically means we've brought our metal lath right down onto those shingles also, which means our last row of nails or staples are going directly through that step flashing, and as they wick water up, we're potentially holding moisture against those holes in that step flashing. So how do we avoid this? Well, one of the ways to do that would be to hold the stone up about 2 inches off of grade. or I'm sorry, off of the shingles. That way we can put our last row of nails hopefully above or near the very top of that step flashing, and we're keeping it away from coming in direct contact with that water on the shingles, so it should not be wicking water up. It doesn't have to look that bad. You can see the siding and the stone have been held up properly off the shingles in this situation, and from the ground, I think that's a pretty acceptable look. The other option, if you don't want to see that 2 inch of clearance, would be to put in a filler or a curb. They're showing a 1 inch board here. I think you could almost go 2 inches. That way, as you bring your step flashing up and your counter flashing out over top, and now as that stone runs up that roof line and you're looking from the ground, that stone almost looks like it's supported by that curbing piece rather than floating up above these shingles. Anytime we've got a retaining wall, we want to make sure that we've got some really good waterproofing on the back and drainage. If we don't, water begins to work its way through the CMU. It carries salts and different chemicals and begins to cause some damage and efflorescence to the stone. If you don't have the opportunity to put really good flashing and waterproofing on the back, the other option would be to put a rain screen on the outside. That way the water's got a chance to get into that rain screen and channel its way out rather than drying out through the stone. Another thing we like to highlight is the cap. Making sure that we've got at least 1 inch of overhang. 2 inches would be much better. And if the cap that you're using doesn't have a kerf, field cutting that in or some type of a drip edge would be important so that any water traveling down that cap doesn't run back in. Make sure that it drops out before it gets to the stone. Now, anytime we're installing over top of masonry that may be used for an entryway sign, some pillars or columns or knee walls, if there isn't a living space on the other side, you can bring the clearance down to 2 inches to grade and 1/2 inch to a paved surface. Let's take a look at wood columns on porches. This is often what we see where the stone is installed right down onto the porch. So we've got two problems. One, down here at the bottom, eventually water is going to begin to work its way in between the porch and that bottom stone. And it could eventually begin to get to the wood of the framing and cause some damage. And so one solution would be to put flashing with a bed of sealant underneath it. I think the bigger problem that we often see is in situations like this where we get 2 layers of paper around the outside. Maybe we even overwrap it with metal lath a little bit. But when we come in and put a cap on here, any sky-facing joint, whether they're grout or caulk or anything like that, will eventually begin to leak. If you look at this cap here, and if you look just off here to the bottom corner, you can see that they haven't even put in finished grade yet. And we're already seeing a hairline crack opening up in this cap. And now if water makes its way down in and there's no flashing or anything on top, water will begin to work on that wood, and it doesn't take long for it to cause some damage. So what we should see, or what we're suggesting, is once you've got your 2 layers of paper around the outside, bring some flashing up across the top and then back down. Now, if you've got a post coming through, you may need to use some peel and stick on that to run from the post down onto that flashing. The detail looks a little bit like this. We've got our 2 layers of paper around the outside and then flashing up the side, across the top, and then back down. And then our metal lath, scratch coat, and then our stone. What it looks like when we don't protect those sky-facing joints, when we allow moisture to get in through the top, it only takes probably about 6 months to a year to develop some hairline cracks from that wood getting wet and expanding and pushing through the metal lath, even if that metal lath and stuff are installed properly. It only takes about 3 years for it to completely deteriorate the inside of that column. And so one recommendation might be, rather than framing this out of wood, would be once you have your posts in here, have your contractor lay out of a CMU the column. Now you want some airspace. You don't want that post to be able to twist and come into contact with your CMU and nudge your CMU. So leave an airspace, and then still want to do some flashing on top to keep water out. But if water does happen to make its way in, we don't have that concern with rotting wood on the inside. Our last topic tonight is going to be around continuous insulation. Increasing energy codes from starting around 2012 began to require larger quantities of insulations in buildings, especially in regions 3, 4, 5, and obviously 6 and 7. But even in regions 1 and 2, we're seeing more insulation being used for the same reason that we do up north. We spend a lot of money to either keep our buildings warm on the inside or cold on the inside, and we don't want to lose that energy and that money we're spending as easily. And what happened is they began to take a look at structures, and they found that at the framing is where they had a lot of their energy loss. We can see the windows here are obviously a high energy loss area, but so is the framing. They call that thermal bridging. We can see where the insulation is in between these studs, but those studs, because they're not insulated, were replaced for energy loss. And so the idea was, let's move that insulation outside of the framing, and therefore we're preventing that thermal bridging. That created some challenges for heavy claddings or even semi-heavy claddings like manufactured stone. And so what BORAL did is we went to work with an engineering firm to figure out how we could install our stone over top of continuous insulation. And now this report is available on our website. You could also get it through your BORAL rep. But what it's going to walk you through is wood framing, steel framing, different gauges of steel framing, and then masonry, whether it's poured or whether it's a CMU. And what this allows us to do is to find out, well, how much insulation are they putting in? And the way we measure it is from the back of the stud, or the face of the stud, to the back of the anchor. And so in between there, we'll probably have a 1/2 inch of wood sheathing, or if it's steel framing, we may have a 1/2 inch of exterior gypsum. Let's say we've got 2 inches of continuous insulation. And then let's say we decided to use a rain screen that was maybe 3/8 thick, like drain and dry. Well, at that point, we've got about 3 inches between the face of the stud and the back of the anchor. 1/2 inch for the sheathing, 2 inches of foam, and another 3/8 or a 1/2 inch for the rain screen. And so if we look at our table here, we've got a lighter 20 gauge stud. If we walk over here, we find 3 inches is our space. It tells us how long our anchor needs to be. But if we go over here, and let's say we've got one of our heavier stone systems that weighs 22 pounds, well, we're not able to do that. But if we bump up to a heavier gauge steel, and then we go over and find that 3 inches of insulation, we go over here, we're able to find that we can do it. We just need to put that anchor every 4 inches. And then we can go over here and find out what type of anchor we need to use. As we progress through, I don't have the slides up here, I'm sorry, but if we go through some of the heavier gauges steels, we're able to do it with some of the heavier stones. And so it's a great option. There are a lot of other systems out there to install stone over top of continuous insulation. You can use those, just make sure that you check for their testing, make sure that they're requiring the proper type of manufactured stone, and then they've got some type of a warranty to back that up. But if you get into a situation where they just want to use anchors to try to minimize that thermal bridging, this report would be a great option for that. So again, just as a recap, we really recommend going out to any one of our stone sites, go to the installation instructions and grab a copy of the NCMA's installation guide. Again, this is where you'll find about 10 to 12 pages of information, paragraphs on papers, lath, wall preparation. And then you're going to find those 40 plus details, again, available in PDF or CAD format. So with that, I'll conclude our presentation. If you have any questions, we'll take those now.
So we do have a couple of questions, Jeff. The first one is, where can we find part 1 of the presentation if we missed it?
And so I believe we've captured the email addresses of everyone that joined in. And so there'll be 2 options. One, if you give us about a week or 2, you should be able to jump out to our sites and find a link to go view those educational series. The other option is we can go through an email where to find those to the folks that have attended this presentation so far.
So someone that was looking at the picture in the section on penetration says, is there anything I can do to fix a situation where the penetration already comes through the scratch coat and the flashing wasn't done behind it?
Unfortunately, I'm not aware of any guaranteed repair. We've seen some folks that have tried to stuff some things in there, but at that point, you're not guaranteed that you're not hitting the top of that primary WRB and not getting interlaced. And so unfortunately, the only proper and safe way to do it is going to be to peel back that lath and scratch coat and make sure that that is air and watertight, flashed properly, and then reapply the scratch coat and lath after.
And then regarding a post coming through a cap in a framed column, is there anything you can do around the post?
So we have seen some where they have used some peel and stick. And so we talked about getting your 2 layers of paper around the outside of the post, bringing your flashing then up the outside, across the top, and then back down the other side. And we have seen some where they've used a good peel and stick that starts on the post and then bends down on top of your flashing. Again, this would be a great place to invest some good money in a really good peel and stick, because that is going to be about the only thing that keeps water from traveling down that post and getting on the inside. That's been my experience. Chris, have you seen anything else that you would add?
The only other thing I've seen is methods where you would use a convex sealant bead and backer rod around the post cap interface.
Okay, that's a good one.
Okay, a couple other questions popping in here as we're talking from our buddy Kurt in Canada. Do you need a flashing on top of the sills at windows?
So I think if we look at the detail in this, I do not see flashing at that point. Chris, are you aware of any? I don't remember seeing any at that point there.
No, I think in most cases, folks are using the flange or self-flashing type windows these days. So in that case, you know, the water would be directed onto the drainage plane as opposed to out onto the surface. So another great place for belt and suspenders using a rain screen, in my opinion. Another question, Jeff, what is the maximum continuous insulation thickness that can be installed without having to install another anchoring plywood layer?
So run that, what's the maximum thickness of the insulation?
What's the maximum continuous insulation thickness that can be installed without having to install another, I'll call it, layer of plywood?
Okay. I think there's a variety of methods that are out there. If you're using the report that BORAL has issued, in most situations, we're going to max out somewhere around 4 inches of insulation, and it does not require sheathing on the outside. The challenge with sheathing on the outside is we begin to add more weight to those anchors. And so by not adding sheathing to the outside, it gives us a little bit more flexibility. Systems that would get thicker than that, I'm not aware of anchors that are able to work that far out with sheathing. The real purpose of that sheathing is to give some support and rigidity to that stone system. The foam that we would require would have a minimum 15 psi, which gives the support to that stone system until that scratch coat's on. And then the good nominal 1/2 inch scratch coat, the 1/2 inch of setting mortar now creates that 1 inch of rigid cement backing. And so really in most cases that sheathing to the outside wouldn't be necessary, unless you've got a different thought on that, Chris.
I don't. That sounds good. Matthew Hoots, I see your question on modular stacked brick. We'll answer that one offline. And that appears to be the last of the questions, Jeff.
Great. Well, I'll wrap it up thanking Chris for taking those questions. I want to thank each one of you for taking time out to be with us today. We hope that you find that the information was valuable. If you have follow-up questions that you didn't get to ask now or come up later, Chris, I think you put our email addresses into the chat box. Go ahead and grab those there. Shoot us an email, and we'd be glad to work with you. Thank you again for your time. We appreciate it, and have a great and safe day out there.